Welcome. So what I have here is y equals 6x squared minus x minus 5. And we want to solve this for when our values of x are going to equal, or when our output values are going to equal 0, we want to find the values of x. And we're going to do this by applying our quadratic formula. So to go from this, the first thing we need to do is make sure that we have it in our standard form. And therefore, we can determine, once it's in standard form, we can determine what our a, which is not 1, our a in this case is 6, our b in this case is -1, and our c is -5. Once we've now determined our a, b, and c from our equation being in the standard form, we can now determine the discriminant. So the discriminant is going to help us to understand what the solutions are for our quadratic equation, or for really our quadratic. So therefore, we have b squared, so it's -1 squared minus 4 times a times c. All right, well, 1 squared is just going to be 1. And then I have -4 times 5. That's a 1. That's going to be positive. OK. So -4 times 6 is going to be -24. Times -5 is going to be a -120. I'm sorry, a positive 120. 1 plus 120 is 121. Now, 121 is a square number. So therefore, we're going to have two real rational roots. And I'll show you why we will, because this is a square number, how that gives us two real rational roots. So let's go and plug in the rest of the numbers that we have for our quadratic formula. So since we already have a -b, the opposite of -b, if I write it like this, I'm sorry, opposite of -1 plus or minus the square root of 121 all over 2 times a, which is 6. All right, so the opposite of -1 is just going to be a positive 1 plus or minus the plus or minus the square root of 121. Since this is a square number, we can take the square root of 121, which is going to be our integer 11, divided by 2 times 6 is 12. So now what we simply need to do is we can just kind of break this apart. And what I could do, you could do this in two separate ways. You could add up your numerators and then divide by 12, or subtract your numerators and divide by 12. And let's just kind of do it both ways. If I said my two solutions are x equals 1 plus 11 divided by 12, and then x equals 1 minus 11 divided by 12. Well, here, 1 plus 11 is 12. 12 divided by 12 equals 1. So you can say x equals 1. 1 minus 12 is going to be a -10. So I have -10 over 12, which we can simplify to -5 over 6. So therefore, we still have two real, and they're also rational roots, or what we call our zeros, to our quadratic equation. So therefore, those are going to be also your x-intercepts that we've all found out. So there you go, ladies and gentlemen. That is how you solve using the quadratic formula. Thanks.